everyone, and welcome to the Deep Dive. Today, we're going to be diving into AWS.
That's right.
We're going to be focusing on some key architectural concepts and best practices.
Cool.
You can think of this like almost a cheat sheet to the cloud for anyone that wants to just get up to speed quickly on AWS. We're going to be taking a look at 2 AWS certification study guides.
Okay.
And these are pretty cool because they give you a very comprehensive overview of AWS. And we'll be highlighting some key takeaways.
Okay, cool.
And, we'll even cover some unusual terms like burst capacity and something called a snowball.
A snowball? Interesting.
Yeah.
What I like about these is that they're perfect for anyone who wants to get a handle on AWS.
Yeah.
So that means if you are studying for certification or just getting at the cloud for the first time, these are a great resource to help get you up to speed.
Yeah, that's great. All right, so let's jump right in. The first thing I want to talk about is compute power. So that's, the heart and soul of any kind of cloud setup.
Right.
And when you're talking about AWS, that means EC2 instances.
Okay.
Now, these are like virtual servers, and they're kind of like the workhorses of your cloud environment. And what I think is super cool about EC2 instances is how fast you can spin them up.
That's right.
Like imagine you need a new server traditionally.
Okay.
This is a process that would take, days or even weeks.
Yeah.
But with EC2, you're talking minutes, sometimes even seconds.
Wow.
That's
a game changer.
Total game changer.
Yeah.
And it's not just the speed, it's the variety. So you've got a whole menu of different instance types. You've got, like your T2s.
Okay.
Those are for everyday tasks. M5s, those are if you need to crunch serious data. And then there are the accelerated computing instances. Those are like super powered for things like 3D rendering or a very complex simulation. Just to give you an idea of the scale, there's an instance called M5D.24x large. Okay, this thing has 96 virtual CPUs and 382 gigabits of memory.
That's a lot.
That is some serious horsepower.
Yeah.
But think about it. As your cloud setup grows, you're going to have a lot of these instances running. How do you keep track of it all?
That's a good question. Well, you want to use
resource tagging.
Resource tagging. Okay, so that's basically like labeling your instances so you know what each one is for. That's going to be really helpful as you scale up. For managing costs, monitoring performance, and even troubleshooting any issues.
That's right.
Okay, so compute power is great.
Yeah.
But you need somewhere to store all that data.
Okay.
Right. So in AWS, you've got 2 key players here.
Okay.
Instance storage.
Okay.
And elastic block storage, which is better known as EBS.
EBS.
Now, the thing about instance storage is that it's directly attached to your server's physical hardware, which means it's temporary. If you terminate, the instance that data is gone, poof.
Wow.
Back in the early days of AWS.
Okay.
That's all they had.
Interesting.
Can you imagine that?
Yeah.
And then along came EBS. Which is persistent block storage.
Persistent.
Yeah. So think of these EBS volumes.
Okay.
Like virtual hard drive that you can attach to your instances. The best part is, even if you terminate the instance, your EBS volume stays safe and sound.
Oh, wow.
Plus, they come in different flavors, optimized for speed, cost, different needs.
Oh.
All right. So let's switch gears a little bit. We've been talking about, processing power.
Yeah.
Let's talk about data storage.
Okay.
So the big name. In AWS storage.
Is S3 short for?
Sure.
Simple storage service.
But don't let the name fool ya.
Okay.
It's deceptively simple because under the hood, it's packing some serious features. One of the most impressive things about S3 is its durability.
Durability.
We're talking 11 nines of durability.
Wow.
That's like, basically your data is incredibly safe.
I like to think of it like a digital Fort Knox.
I like that.
For your files. But S3 isn't a one-size-fits-all solution. It offers different storage classes, each designed for specific needs. Yeah. You've got standard, that's for your frequently accessed data, one zone IA if you need something that's more cost-effective for data you don't access as often. And then you've got reduced redundancy if you want to. Prioritize cost savings. And that's one of the things I really like about AWS. It's all about giving you choices and flexibility to tailor solutions to your specific needs. And then there's Glacier. So this is if you need long-term, low-cost storage, like for things like backups or archives, Glacier's your go-to. It's like digital deep freeze for data that you need to keep safe, but don't access very regularly. Now, it's interesting how Glacier is technically part of the S3 family, but it has a different focus.
So what's different?
Well, the retrieval times are much slower with Glacier. We're talking hours.
Hours?
Not milliseconds. But that trade-off comes with a significantly lower cost.
It makes sense.
All right. So we've got our virtual servers humming. We've got our data tucked away safely. What's next in building out our AWS world?
Yeah. What about networking? No cloud setup is complete without networking.
Networking.
It's the backbone of everything.
The backbone.
And in AWS, it all starts with a VPC.
Okay.
Or virtual private cloud.
Virtual private cloud.
Essentially, it's your own private network within AWS.
Yeah.
And it gives you total control over your networking environment, from defining subnets
so subnets
to setting up security groups.
So subnets are like dividing your VPC into smaller, more manageable chunks.
Yeah.
Kind of like creating different rooms in a house.
Exactly.
Each with its own purpose and level of access.
That's a great analogy.
Yeah.
And to make sure things are locked down tight,
you've
got security groups. And NACLs.
Yeah.
Or network access control lists.
Okay. Now this is where I always get a little confused. What's the difference between security groups and NACLs?
And the common question.
Yeah.
They both sound like they're in charge of security.
Yeah, they both sound like security.
Right. Think of security groups as working at the individual instance level.
Individual instance level.
Like guarding specific computers.
Okay.
NACLs, on the other hand, apply to entire subnets.
Entire subnets.
By controlling access to a whole wing of your virtual building.
So security groups are for individual instances.
Yeah.
NACLs are for the entire subnet.
That's right.
Okay, that makes it much clearer. So you've got these layers of security, but how do instances inside a private VPC actually connect to the internet?
That's where NAT comes in.
Yeah.
Network address translation.
Network address translation.
It's like having a dedicated receptionist
for
your network, handling all the external communication, while keeping your internal network safe and sound.
Okay, cool. So we've got our virtual servers running. We've got our data tucked away safely. Our network is all set up. What about databases?
Databases.
Where does all that critical application data live in AWS?
Well, let's start with a familiar concept.
Okay.
Relational databases.
Relational databases.
Think of them as super organized spreadsheets.
Okay, like rows and columns.
Rows and columns. They're perfect for structured data.
Structured data.
Things like customer info.
Okay.
Or financial transactions.
Right. And AWS has a service for that, right?
You got it.
RDS, or Relational Database Service. It manages all the behind-the-scenes stuff.
That's right.
Like provisioning, patching, backups.
All that good stuff.
And just like with EC2 instances, RDS offers a bunch of options to choose from.
It does.
You can go with popular database engines like MyFull, PostgreSQL, even SQL Server or Oracle.
Wow.
So you're telling me I can run a full-fledged Oracle database in the cloud without having to manage any of the infrastructure?
That's the beauty of the cloud.
That's pretty slick. But AWS doesn't stop there.
No, they don't.
Does it? What about other types of databases?
Right, they've got Redshift.
Redshift.
Which is a data warehousing solution for handling massive data sets.
Massive data sets.
And then there's DynamoDB.
DynamoDB.
A NoSQL database.
Yeah.
Known for its flexibility and its ability to scale like crazy.
So basically, whatever your database needs, AWS has you covered.
Pretty much.
But with all these options, how do you know?
That's a good question.
Which one is right for you?
Well, choosing the right storage type.
Okay.
And instance class for your RDS database can make a huge difference.
A huge difference.
In performance.
Okay.
You've got general purpose SSD for most workloads, provisioned IOPS SSD for applications that need lightning fast response times, and even magnetic storage for less demanding tasks.
Okay. So it's not a one-size-fits-all situation.
No, it's not.
You need to think carefully about what your database needs to do.
Exactly.
And pick the storage. That will make it sing.
You got it. And remember, AWS gives you the tools to analyze your workload and make informed decisions Services like CloudWatch
CloudWatch
can help you understand your database performance so you can choose the right storage and instance types.
Okay, so we've touched on compute, storage, networking, and databases. But we can't forget about security.
Security.
That's a big one.
It is.
Especially in the cloud.
Especially in the cloud. And in AWS. The gatekeeper is IAM.
IAM.
Or Identity and Access Management.
Identity and Access Management.
They're all about controlling who has access to what.
So it's like having a super strict bouncer for your cloud environment, making sure only the right people get in.
That's right.
And that they can only do what they're supposed to do.
You got it. IAM lets you create users, groups, and roles, and then assign specific permissions to each. You can get incredibly granular. Controlling things like which S3 buckets a user can access.
Okay.
Or which EC2 instances they can start or stop.
That sounds incredibly powerful.
It is.
But with all that granularity, doesn't it get complicated?
You're right. It can get tricky.
To manage all those permissions, especially as your AWS environment grows.
AWS provides tools and best practices to help you manage IAM effectively.
So there are ways to make it easier.
Exactly. For example, you can group users with similar permissions together, which simplifies applying policies.
So you can create like groups of users with similar permissions.
That's right.
Okay, that makes sense. But security isn't just about controlling access.
No, you're right.
Right. It's also about keeping an eye on things. And making sure you have a record of what's going on in your AWS environment.
That's where services like CloudTrail, CloudWatch come in.
And CloudWatch.
CloudTrail acts like a security camera, recording every action taken by users and services. And CloudWatch is your dashboard giving you insights into resource performance, potential issues, and suspicious activity.
So CloudTrail's like the detailed logbook.
You got it.
And CloudWatch gives you the real-time overview.
Exactly.
Work together to help you maintain a secure and compliant cloud environment.
That's right.
Okay, so we've covered a ton of ground here: compute, storage, networking, databases, security. But let's shift gears for a minute and talk about performance. What good is a cloud infrastructure if it's slow and sluggish?
Yeah, you need things to be fast. Performance is key. And the good news is that AWS has a whole toolkit for optimizing your cloud setup and making sure your applications run like lightning.
Oh, I like that. Like lightning. So, for instance, I've heard about this thing called Elasticache. It's a caching solution, right? Like storing frequently accessed data in a super fast memory layer so your applications can just grab it instantly.
Exactly. It's like having a shortcut for your data.
Oh, I like that. A shortcut.
Elasticache offers different engines like Memcached and Redis, each with its own strengths. Memcached is super simple and scales really well, while Redis has more advanced features like data persistence and pub/sub messaging.
So as always, it's about choosing the right tool for the job. And another performance trick is compressing data before you move it around, right? Like zipping up a file to make it smaller.
You got it. Compression reduces the amount of data that needs to travel over the network, which means faster transfer times. And AWS makes it easy to implement compression in different ways. You can configure S3 to automatically compress objects, or you can use CloudFront to serve compressed content from edge locations around the world.
Speaking of CloudFront, that's a content delivery network, or CDN, right? What's the deal with those?
CDNs are like having a network of mini servers scattered all over the globe. They cache copies of your content closer to your users. So when someone wants to access your website or download a file, they get it from the server that's closest to them, resulting in super fast loading times.
So it's like having a global relay race for data, making sure it gets to the finish line as quickly as possible. But performance isn't the only thing we need to think about, right? There's also the cost of running all this stuff in the cloud.
You're absolutely right. Cost optimization is just as important as performance optimization. And the good news is AWS provides a bunch of tools and strategies for managing your cloud expenses effectively.
Like, for example, using reserved instances for your EC2 servers. If you know you need a server running 24/7, reserving it can save you a bunch of money compared to paying on-demand prices.
Right, and AWS offers different types of reserved instances to fit different needs. Standard RIs are for long-term commitments, while convertible RIs give you more flexibility to change instance types or regions if your needs change down the road.
And then there's the spot market for EC2, where you can bid on spare computing capacity at potentially much lower prices. It sounds a bit like an auction, though, right? Is there a catch?
There is a catch spot. Instances can be interrupted with short notice if the spot price goes up. But for workloads that are flexible and can handle interruptions like batch processing or scientific computing spot instances, can be a great way to save money.
So it's like a high-risk, high-reward game for cloud computing. But if you play your cards right, you can get some serious discounts besides reserved instances and the spot market. What are some other ways to optimize costs in AWS?
One of the most important things is to right-size your resources. It's about making sure you're using the right instance types, storage options, and services based on your actual usage patterns. AWS has tools like Trusted Advisor and Cost Explorer that can help you identify areas where you might be overspending.
So it's like decluttering your cloud environment and getting rid of anything you don't actually need. And I bet automation can help with cost optimization too, right?
Absolutely. Automation can streamline your operations, reduce manual errors, and ensure that you're using resources efficiently. AWS services like CloudFormation and Systems Manager are great for automating tasks like provisioning, configuration management, and patching.
All right, so we've talked about making our cloud infrastructure fast, secure, and cost-effective, but there's one more critical piece of the puzzle, high availability.
High availability is all about designing your applications and infrastructure to be resilient, able to bounce back from failures, and minimize downtime in the cloud. That's about taking advantage of the redundancy and scalability of AWS to build systems that can keep running no matter what.
And that's super important for mission-critical applications, right? The ones that can't afford to go offline, even for a short period. E-commerce sites, financial applications, healthcare systems.
Exactly. Downtime can mean lost revenue, damaged reputation, or even life-threatening situations. So high availability is about minimizing risk and making sure your applications are always up and running.
So how do we achieve this high availability nirvana in AWS? What are the key strategies?
One of the most fundamentals is designing for failure. That means anticipating potential points of failure and building in redundancy at every level you can deploy your application across multiple availability zones. Those are like separate data centers within a region.
So if one availability zone goes down, your application can keep running from the other zones. It's like having a backup power generator for your cloud infrastructure. But how do you make sure traffic gets routed to the healthy servers?
That's where elastic load balancing comes in. It acts like a traffic cop, distributing traffic across multiple instances and automatically redirecting traffic away from any unhealthy instances.
So even if a server goes down, the users won't even notice because the load balancer will seamlessly send them to a healthy server pretty slick. But what happens if there's a sudden surge in traffic and your existing servers can't handle it?
That's where auto-scaling comes in. It automatically adjusts the number of instances based on demand, ensuring that you always have enough capacity to handle those traffic spikes. It's like having an elastic infrastructure that expands and contracts as needed.
So you're always prepared for the unexpected, but you're not wasting money on resources you don't need. But high availability isn't just about the infrastructure, right? It's also about the application itself being able to handle failures gracefully.
Absolutely. Implementing fault tolerance at the application level is crucial. You can use techniques like retry logic, circuit breakers, and graceful degradation to build applications that can withstand failures.
So it's like building in backup plans and safety mechanisms within the code itself. But how do you know if all these high availability measures actually work? How do you test them?
Testing is essential. There are various approaches, including chaos engineering, load testing, and failure injection. Chaos engineering is about deliberately introducing failures to see how your system responds. Load testing simulates real-world traffic patterns to see how your system performs under pressure, and failure injection involves deliberately causing specific components to fail.
It sounds kind of intense, but I guess you need to be prepared for anything, right? So we've covered a lot of ground in this deep dive, from the basics of AWS to more advanced concepts like security, performance, cost optimization, and high availability. It's been a wild ride.
It has. And, we've only scratched the surface. AWS is a vast and ever-evolving platform. But what we've explored today are the foundational concepts that will help you understand the core principles and best practices for building secure, resilient, and cost-effective cloud solutions.
So for anyone listening who's feeling a little overwhelmed, don't worry, it's a journey, not a race. Take your time, experiment, and don't be afraid to ask for help. The AWS community is incredibly supportive, and there are tons of resources available online.
That's right. Embrace continuous learning. Stay curious, and most importantly, have fun exploring the amazing world of AWS.
And that is it for this deep dive into AWS. Thank you so much for joining us today.
Thanks for having me.